go ahead and move on to 4.7. 4.7, triangle congruence. And we have this thing here that says Cpctc. Okay, this stands for congruent parts in congruent triangles are congruent. So no. So it is actually what? Corresponding parts in congruent triangles are congruent, okay? Right. Which kind of makes sense, right? So in other words, if I have two triangles that are congruent, so the congruent parts in congruent triangles are going to be congruent. So if I told you that I had two triangles and they were, and the statement that I give you is ABC is congruent to triangle DEF, okay, I can actually say, without even looking at the picture, I can say that angle ABC will be congruent to angle DEF, or I can say the segment AC will be congruent to DF. Okay, as long as I am keep the same order. So segment CB would be congruent to segment FE, right? Because we're just I'm reading off the congruent statement that tells me that, well, if these are congruent, then the parts, each part, the corresponding part will be congruent also. Okay, so that's basically what this is. Okay, and that's basically what 4.7 is. Let's see if we can do example number 1. Example number 1 says, to design a bridge across a canyon, you need to find the distance from A to B. Okay, but we are also told that we have, so the river runs through here, and the canyon runs through there, I'm sorry. And we have EDCBA, and we are given that these two are like that. We're also given that this is 500 and this is 500, okay? And what do we know here? We also know that DE is 600. This guy here is 600. And we're trying to find out what this guy is, right? So we need to find the congruent statement first, right? So are these two triangles congruent? Well, I have one leg that are the same. So I have a side, and a side, right? I have a side. I also know that this angle is going to be congruent. Those two angles are congruent because they are vertical angles, okay? But I also know that this angle is congruent, right? So what theorem am I using? I have SSS, SAS, AAS, ASA, and I have this. Which one am I using here to say that these triangles are congruent? Which can I use? Kayla. Kayla? Kayla home? Is Kayla home? Kayla's not home? Holden, what can I use here?
Can't you use hypotenuse leg?
Huh?
Hypotenuse leg.
Hypotenuse leg. But I don't know that these two hypotenuses are the same, do I? Because these would be the hypotenuse, right? And this would be the leg. I get the leg part, but we don't know that the hypotenuses are the same. So that's not it. Anybody else?
Side angle side.
Okay, side angle side. Which two sides do I know? I know this one side, and I know these two angles. Which other side do I know?
You know the 600.
Do I know that these two are the same?
Angle, side, angle.
Aha, angle, side, angle, right? Because angle, side, angle, side, angle, right? So it's going to be the angle, side, angle, right? From the angle, side, angle, I can now say that the triangle ABC is going to be congruent to triangle what? A, the counterpoint would be E, AB, so it'd be D, C, right? Because of angle, side, angle, I can now say that these two triangles are congruent, and therefore DE would be the same as BA. BA, that's what we're trying to find, right? We're trying to find BA, right? So now I know that BA is going to be 600. Okay, all right. So that's how that would work. That's example number 1. Let's go to example number 2. Example number 2. Prove given I have 2 triangles that look like this. And they are A, B, C, D. Given that AB and AB and DC are congruent, and angle ABC and DCB are congruent, so angle ABC, this angle here, and angle DCB, this angle here are congruent, okay? Prove that angle A is equal to angle D. I want to prove that this angle here and this angle here are the same. Okay. So, what needs to happen here? I could try to use these two triangles here and say that they are congruent, but all I know here is a side and an angle, right? What else do I have? Is there anything else that I have?
You know that the thing in the center makes them vertical angles.
There you go. So you can do these two angles are the same, right? And then which one would I use? Which am I using? SSS, SAS, or what am I using here? You are correct so far. Which one am I using? I'm using a side, angle. So it's an angle, side, right? Angle, side, right? So it'd be angle, side, correct? And because of that, if I called that O, I could say that triangle AOB is congruent to triangle DOC, and therefore angle A would be congruent to angle D. This is a perfectly legitimate proof, okay? Now the book does not go this way. The book goes a different way, and I'll talk about that. So the book does not talk about the vertical angle here. The book talks about, the way the book goes is that they're going to prove that this guy, this triangle here is congruent to this triangle here. Okay, and the way you go about doing that is that you have, they're going to share this side. So it's going to be side, angle, side, side, angle, side. Okay, they're going to use side, angle, side here. They're going to use this guy and say triangle ABC is congruent to a triangle DCB. In other words, this triangle here is going to be congruent to this triangle here. Okay, so therefore, since these are congruent, angle A is going to be congruent to angle D because they're corresponding parts. So they're going to be congruent. Okay, all right, good job. So that's example number 3. No, that's example number 2, not 3. Jumping ahead of ourselves here. And so let's do example number 3. Example number 3, we have you. So I have these guys are parallel. E, G, F, D. Okay. So these two are parallel. Not only parallel, they are actually also congruent. Okay. Prove that ED and GF are parallel. Prove that these two guys are parallel. Okay. So the way that I would do that is I would go like this. I would put my transversal that way. Now what can I say? I can say that this angle and this angle are the same. Can anybody tell me why they're the same? What kind of angles are these? If these two are parallel, and this is my transversal, right? These are alternate interior angles, right? They're alternate interior angles. So therefore, these two angles are the same, which means that since they share this leg here, this side, this line, this segment here, you get side, angle, side, side, angle, side are the same, right? So from SIS, I can see that the triangle FDG is going to be congruent to triangle EGD. Okay. And what am I trying to prove? I'm trying to prove that ED and GF are parallel. Okay. So can I say that? Since they're parallel, since these two triangles are congruent, okay, so I skipped a step here, okay. Since these are congruent and parallel, these two triangles are congruent, I can say that this guy here and this guy here are the same, right? So from these two here, well, actually, I'm doing it the wrong way. I can say that these two angles are the same because of the congruence, because of the triangle congruence, right? The triangle congruence. Since these two triangles are, since this is the same, I have angle DGF. DGF is congruent to angle GDE. GDE. So these two blue angles are congruent. But if you look at the blue angles from these two lines and this transversal, they are another alternate interior angles, right? Since the alternate interior angles are congruent, I can now say that these two are parallel. Okay? So that's why I can say that ED is parallel to GF. Okay? All right. And your 2-column proof is there, written right there. So you can just follow that. Okay, last but not least, we have example number 4. And in example number 4, we're actually going to use the coordinate plane to find congruence. Okay, so we're going to have, given A, B, C, D, E, F, prove that angle A, B, C, and D, E, F are congruent. Okay, so I have A is 2, 3, 2, 3. We'll call is A. B is 5, -1, 5, -1. This is B. Then we have C, which is over here. I have this triangle. A was what? 2, 3, 5, -1, and 1, 0. Then I have D, E, F. D is -4, -1. So this is D. And then I have E, which is up here. 2, 0, I mean 0, 2, right? 0, 2, and then I have F, which is -2, 1, so it's going to be around here. -2, -1, and -1, -2, I'm sorry. -1, -2, and this is F. And have these triangles. So, and I'm trying to prove that ABC, this angle here, is congruent to angle DEF, DEF, this angle here, right? So in order to prove that, what I really need to prove is that these two triangles are congruent, right? If I can prove that, then to the corresponding parts, I can say that these two angles are congruent, right? So the way to do that here is going to be really 1, because there's no way I can calculate the angles here, right? I mean, there is a way, but you guys just don't know how to do it yet, okay? So there is a way, but we don't know that yet. So we can't calculate the angles. So that leaves us only with one option, and that option is to calculate all the lengths and see if they are congruent, right? So let's calculate the lengths and see what we have here. So DE, the corresponding part to DE would be AB, right? So let's compare DE and AB. So DE and AB, DE is from here to here, and the equation goes x1 minus x2, right? x1 or x2 minus x1, x2 minus x1, so it'll be 0 minus 4 squared plus y2 minus y1. 2 minus 1 will be 2 plus 1 squared, right? Look at A, what do I get here? At AB, what do I have? A and B, so I'm going to go x2 minus x1, 5 minus 2 squared, and then y1 minus that guy squared. All right, so let's do this out. What do I have here? I have 4 squared, which is 16. I have 3 squared, which is 9. 25, square root of 25 is 5. So this is 5. I get here, I have this is 3 squared, which is 9, plus this is -4 squared. -4 times -4 is 16. Square root of 25, again, which is 5. So I found that these two are the same. Okay? By the same thing, let's do DF and AC. So let's compare DF and AC. DF. So -1 to -4, -1 minus 4 is +4 squared, plus -2 minus 1 is +1 squared. And then I'm going to have AC. AC is here to here. So I'm going to go 2 minus 1 squared, and I have 3 minus 0 squared. So what I'm going to get here, I'm going to get 3 squared, which is 9. Here I get -1 plus -2 plus 1, so we get -1. -1 times -1 is 1. We get square root of 10 here. Over here I get 2 minus 1, which is 1. 3 minus 0, which is 3. 3 squared is 9. Square root of 10. Again, DF and AC are the same. Okay. So now all I need is to have these two be the same. So let's do that, the very last one. Okay, so I'm going to erase all this. So yes, this is a little involved, okay? It's a little tedious, but you just gotta, kind of take it a little slow and go. All right, so we were doing FEF. So we're comparing EF to BC, EF, -1 minus 0 squared. I'm gonna have -2 minus 2 squared. It's gonna be square root of this is 1 plus -2 times -2 plus -2 is -4. So -4 times -4 is 16. Square root of 17. Let's do BC. 5 minus 1 squared plus -1 plus 0 minus 0. And actually minus 0 squared. 5 minus 1 is 4. 4 squared is 16. -1 squared is 1. Square root of 17. Again, they are the same. So I have proved that all 3 sides are the same. So from side, I can say that these triangles are congruent. So I can say that the congruent statement, okay, which is important, and ABC is going to be DEF. Triangle DEF. Therefore, angle DEF is going to be the same as angle ABC. So two angles are congruent. Okay? And we're done. We're done for this section.